everybody, and welcome back to another Miss Pollard Math YouTube video. Today we're going to be going over radicals and more specifically solving radicals and simplifying radical expressions. And me personally, I love to say this is a rat's topic. Anyway, so let's get started on solving our radicals. So I am with a constant plus a radical term equaling our variable. And every single time we have this problem, we're going to try to get the radical by itself. I know that the inverse operation of a square root is to square it. If I square this whole side, that's using concepts that are way above my knowledge at the moment. So I'm going to move this term over so I have just the radical that I can square. So I'm going to subtract by 6, and I get the square root of 76 minus 6n equals n minus 6. Now I have that radical by itself on the left-hand side. Like I said before, inverse operations, to get rid of that square root and leave just what's under that radical, I have to square both sides. So I square this side, and I'm left with the 76 minus 6n, and that means I have to square this side as well. I know that this is a special product rule. When I have the same binomial raised to a square, that formula is a squared minus 2ab plus b squared. That minus is coming in because there's a minus in between these two terms. So I am going to square my a, my first term here, which is my n. So I'm going to do equals n squared minus 2 times my n, which is 2n, times my 6, which is 12n. And then I do 6 times 6, which is 36. Now I want to get everything on one side. I'm going to get it on that right-hand side so my n squared is positive. I want my n squared to be positive because then I can factor when a is 1, and that's a little bit easier. So I'm going to subtract 76. I'm going to add 6n. And I get n squared minus 6n minus 40. And now I have to factor that. So I have to think back. What multiplies to negative 40 and adds to negative 6? That would be n minus 10 and n plus 4. I have to get my zeros though. So my zeros are 10 and negative 4. Now I must plug it in because I can have extraneous solutions where we solve this problem, we got one of our answers, when we plug it in, it doesn't work. So that is going to be called an extraneous solution. So I plug in 10. 10 times negative 6 is negative 60. 76 minus 60 is 16. The square root of 16 is 4. So now I have a 4 even for this, plus my 6 does give me the 10 of my n that I wanted. So my 10 works. Let's plug in negative 4. That's 76. Negative 6 times negative 4 is 24. So 76 plus 24 is 100. The square root of 100 is 10, plus 6 is not negative 4, like we want it to be. So that's going to be my extraneous solution. This does not work. Sometimes both equations or both solutions might work. So we might have two answers to this problem, or in some cases neither work and they're both extraneous solutions, so that would be a no solution problem. So every single time you have to check because you have to tell your teacher which portion is the extraneous solution and which portion is our true answer. Now let's look at a problem where we're simplifying radicals. And the most important portion here is knowing what our perfect squares are because we're trying to divide those out. So we think about it, it's all the numbers, they're integer values, that when we multiply them by themselves, that's our perfect square. So if I think 2 times 2 is 4, then we have 9, we have 16, we have 25, we have 36, we have 49, 64, 81, 100, 121, so on and so forth. So we're trying to break up our radicals so we have a perfect square that we can square root to take out and leave us with the smallest number possible inside the radical. So 18, I think of my perfect squares list that I just listed, that can be broken up to 9 and 2. I square root 9, and that's 3. The square root 9 is 3, so I multiply this by 3. Negative 2 times 3 is negative 6. It leaves me with that square root of 2 on the inside. 3 I cannot break up any further. 3 cannot be divisible by any of our other perfect squares, so I just add 2 plus the square root of 3. We have 12. 12 is divisible by our perfect square of 4. So I have the square root of 4 times the square root of 3. The square root of 4 is 2, so we multiply this by 2. So I get plus 6 square root of 3. Our last portion, we have the square root of 8. Once again, the square root of 8 is divisible by 4, and leaves a 2. So the square root of 4 is 2 times a negative 3 is negative 6, square root of 2. I now need to combine my like terms. My like terms are the ones that have the same radical expression attached to it. So I have negative 6 square root of 2 and negative 6 square root of 2, which is negative 12 square root of 2. Then I have 2 square root of 3 plus 6 square root of 3, which is 8 square root of 3. We're just combining our like terms. It's almost like we have an x and a y. We can't combine those because those are not like terms, and that is how we simplify radical expressions when we're adding or subtracting them. Let's try some more problems with different operations to see how we would simplify those type of problems. Now we have radical multiplication, and what we want to do is only multiply what's on the outside by the outside and the inside and the inside. So we have 5 and negative 5. Multiply them together, I get negative 25. Now I have my radical. 15 and 3 gives me 45. P squared and p squared, I add their exponents, I get p to the 4th. Q5 and Q4, I get q to the 9th. Now that I successfully combined them, I need to break them up. I need to get them in simplest form. So 45 breaks up to 9 and 5. So the square root of 9 is 3. So I'm going to multiply this by 3. And I get negative 75 on the outside. And it leaves on the inside the 5p to the 4th, q to the 9th. Now, though, I can break up my variables. I'm going to break them up in terms of squares. So in p to the 4th, I have, I'll just look at the radical for now. I have p squared times p squared. For the q's, there's 9 of them. So I have 2, 4, 6, 8, and I'm left with 1 extra. When I have the squares, those are the ones I can take out. So I'm going to take out 1, 2 p's. So that's p squared. I can take out 1, 2, 3, 4 q's. So I'm left with q to the 4th. And on the inside now, I have 5q. And that's how I simplify. I think it's easiest to break up our variables by squares. I circle them to know what I'm taking out. The reason why when I take it out, it's just 1 and 1, which makes 2, is because the square root of p squared is just p. P times p is p squared. So when you square root it, it's just a p. So there's 1, 2, 3, 4. I have 4 here now. So this would be my final answer. Let's try some other operations. Now I have this problem where I have to use a concept that I saw before for polynomials. It's called FOILing. So I'm going to multiply the first term with the first term. So negative 4 times negative 2 is 8. You can only do the outside with the outside, the inside with the inside. So 6 times 5 is 30. Now I do this one with this one. Negative 4 times 3 is negative 12. 6 times 3 is 18. Now I have these two. I get negative 6. 2 times 5 is 10. And then these two gives me 3 times 3, which is 9. 2 times 3, which is 6. Let's say these were both square root of 2's. The square root of 2 times the square root of 2 is just plain 2. So I'd be multiplying the 3 times the 3, which is 9. Square root of 2 times square root of 2, which is 2. So I do the 9 times the 2, which is 18. Once again, we don't have that problem, but I just wanted to tell you that just in case you see a problem like that. Now we have this, but I have to break it up if I'm able to. So I have 30. Is that divisible by 4? No. Is that divisible by 25? No. Trying to think of these. 9, 16. None of these. So I'm going to leave it as the square root of 30. Is the square root of 18? Yes, we just saw this. We did 9 and 2. So the square root of 9 is 3. So we multiply this by 3, and I get negative 36, square root of 2. So none of those square roots I'm able to combine, so I'm just going to write it out as 8, square root of 30. Minus 36, square root of 2, minus 6 root of 10, plus 9, square root of 6. I know 30 looks a little big, but when we went through our perfect squares, we were not able to evenly divide them, so that would be our final answer. Let's look at another problem where we're going to have to use division now. Now we have a division problem. I like to simplify as much as I possibly can. So let's look. The 2 and the 3 can't be simplified, so I leave it as is. However, I cannot do 2 and 20, let's say. Like if there's something on the outside of the radical, something on the inside of the radical, I can't simplify them together. A lot of people are getting confused with that. You can only simplify inside the radical with inside the radical. So I'm going to divide both of these by 4 because I see they're divisible by 4. So when I divide this by 4, I get 4, I get a 5. Now I'm going to simplify my exponents for my variables, going all the way back to our exponent rules. 2 and 4, that leaves a 2 in the denominator. So I get 2 square root of 4 over 3 square root of 5. I'm left with an x squared in the denominator. Here I have y to the third and y. I'm left with a y squared in the numerator. There are multiple ways I can go about this. I can simplify this by taking out what I want to take out. I can simplify that as well, or we could just multiply by that radical. We cannot have a radical in the denominator, so the way to get rid of it is to multiply by that radical. I'm going to pull out the x squared. The square root of x squared is just x, so I'm going to put x on the outside and leave the square root of 5 on the inside. So we have 3x square root of 5. Like I said before, you're not allowed to have a square root in the denominator, so we multiply both the top and the bottom by that square root. Not by its coefficient though, just by the square root. So this becomes 2 square roots of 20y squared over, like I said before, the square root of 5 times the square root of 5. That's the square root of 25. Or another way to memorize it is, if you're multiplying a radical by itself, it's just what's under the radical. So square root of 5 times square root of 5 is just 5, times the 3x gives me 15x. I need to simplify my radical here. Like we saw, it's 4 times 5. Square root of 4 is 2. So multiply this by 2, and I get 4. Y squared, the square root of y squared is y, so I can take a y out. Square roots, I'm left with 5 on the inside, over 15x. I cannot simplify that 5 and that 15. One's inside the radical, one's outside. If we had something here like a 10 and a 15, you must simplify it because they're both on the outside. But because we don't, that's going to be my final answer. As you can see, there's multiple ways of doing this. I could have, like I said before, simplified these two, and then I wouldn't have had to do it over here. Either way, you're going to get the same answer. It's just determined which process you have to go through. What you have to do next is based off of which step you take first. Our last problem is going to be using our conjugate, and we'll see how to do that shortly. Now we have this problem, and for this problem, we're seeing 2 radicals in the denominator. And like I said before, we're not allowed to have radicals in the denominator for it to be fully simplified. So what I'm going to use is the term called a conjugate. And the conjugate is a way for us to simplify these without having to do a whole string of work. So all we have to do is change the sign in between. So if this is a plus, it becomes a minus. If it's a minus, it becomes a plus. When I say change, I mean when we're multiplying by. We're going to multiply by this binomial and just change the plus to a minus. So I'm going to multiply by 5, square root of 5, minus 3, square root of 3. And if I do that on the bottom, I have to do that on the top as well. When I do that, this bottom is another one of my special products where it says the first squared. So this times this, you can FOIL it out, and you'll see the middle term goes away, but for our easier terms, I'm just going to take the first one squared. So I do 5 squared, which is 25. Square root of 5 times square root of 5 is square root of 25, which is 5. So I do 25 times 5, which is 125. So in the denominator, I'm going to have 125. Minus 3 squared is 9, times the square root of 3 with the square root of 3. That gives me 3. So 9 times 3 is 27. Over, we FOIL. 2 times 5 is 10. 6 times that 5 gives me square root of 30. 2 times that negative 3 gives me negative 6. 6 times 3 is 18. 4, now negative 4 times the 5 gives me negative 20. Square root of 10 from that 2 times that 5. And finally, negative 4 times negative 3 is 12. 2 times the 3 is square root of 6. 125 minus 27 gives me a 98 in the denominator. I'm going to write this over here. So I get a 98 in that denominator. In the numerator, I get the 10 square root of 30. That can't be simplified. I get negative 6 square root of 18. We saw that breaks up to square root of 9 times square root of 2. Square root of 9 is 3 times negative 16. Negative 6, excuse me. Square root of 3 times negative 6 is negative 18. Square root of 2 minus 20 square root of 10 plus 12 square root of 6. This is very long. Now I look at all their coefficients. All their coefficients are divisible by 2 with the denominator as well. So I'm going to divide them all by 2 so I have my simplified formal answer. So my final answer, the long-winded answer, is 5 square root of 30. I cannot divide by inside the radical, only the coefficients because this doesn't have a radical, minus 9 square root of 2 minus 10 square root of 10 plus 6 square root of 6. And in the denominator, I do 98 divided by 2, which gives me 49. So I know this was a big problem, a very extensive problem, but what we have to do is make sure we are multiplying by the conjugate, which we change the sign. You have to FOIL. Once we FOIL, we're able to simplify all those coefficients. We must. As you can tell in the denominator, we got rid of that radical just like we wanted. That's the reason we multiplied by the conjugate. So simplify all those coefficients or you will lose points. And that would be my final answer. So I hope this video helped with solving and simplifying radicals.